Hello, welcome to Chapter 1, Section 2. This section is much like the last in that it deals more with terminology than notation, but you'll want to pay attention to those words that are defined in your lecture notes. Make sure that you're pausing the video and trying to do the exercises as you're prompted to get the most out of both the video and the notes. Also remember to have those done by the time you come into class next time, as we'll be doing practice work on both this section and the previous one when we get together in class. And I will need to see that you finish the lecture notes. Also, on a personal note, please excuse the sound of barking dogs in the background on this one. My neighborhood has lots of friendly hounds that like to talk to each other. Okay, let's get started. Welcome back, everyone. In this video, we'll be discussing Chapter 1, Section 2, Data Classification. Let's continue a discussion that we started in the previous video, where we talked about different ways to characterize data. One way was sets, population versus sample. Now we're going to explore the other two ways we characterize data, namely how to distinguish between qualitative data and quantitative data, and how to classify data with respect to the four levels of measurement: nominal, ordinal, interval, and ratio. So here we go. Data sets consist of two types of data, the first of which is qualitative data. This consists of attributes, categories, or labels. In other words, non-numeric entries. The other type is quantitative data, or numerical measurements or counts. The first type, qualitative data, could be things like your major, your place of birth, your eye color. These are categories or categorical data. You can't calculate an average major or birthplace. That doesn't make sense. The second type, quantitative data, could be things like age, weight of a letter, temperature, all numerical measurements or counts. Mathematical calculations make sense with quantitative data, and you can find things like the average age of individuals in a graduating class, or the deviations amongst day-to-day temperature readings. Let's practice classifying data by type. The table shows sports-related head injuries treated in U.S. emergency rooms during a recent 5-year span for several sports. Pause the video and see if you can figure out which data are qualitative data and which are quantitative data. Well, the first column includes the names of sports. That is categorical, not numerical. So the first column of type of sport would be qualitative. What about the second column, head injuries treated? There we find numbers, and they seem to be the type that it would make sense to use in mathematical calculations. We can, for instance, figure out what ratio of head injuries there are in football versus hockey. So the second column, head injuries treated, would be quantitative. So why is all of this important? Because the type of data you're working with will determine what kind of statistical procedures can be used while evaluating the data. Let's look at another way of characterizing data, and that is by its level of measurement. There are 4 levels of measurement. The first level is called nominal, and it will help you remember what's included in this level if you think of the root word nom, or name. Nominal level of measurement includes only qualitative data or categorical data like names, labels, or qualities. No mathematical computations can be made with nominal level data. The second level of measurement is ordinal. This level can include qualitative or quantitative data. The data can be arranged in some type of order or ranked, but calculating the differences of two pieces of data is not meaningful. The third level of measurement is interval. This level includes only quantitative data. This data can be ordered, and differences between the data entries is meaningful, meaning mathematical computations are used at this level. However, a 0 at this level is not an inherent 0, which means that it only represents a position on a scale, not the absence of something. A good example would be temperature. You can subtract temperatures, and there is a 0, but 0 degrees Fahrenheit does not mean that temperature does not exist. It means that the temperature is at a certain point on a scale. The fourth and last level of measurement is the ratio level of measurement. It is similar to the interval level with a few key differences. It too includes quantitative data, and differences can be found among the data entries. But with the ratio level, a 0 entry is an inherent 0, which implies the absence of something. And entries can be mathematically calculated as ratios, or one divided by another. An example of the inherent zero would be a data set that includes amounts of money. A zero data entry would mean $0 or zero money, which would be significant and have meaning as the absence of something. Also, you can divide and compare data entries with money in this way. Let's look at some examples. Look at the data set in the first row at the nominal level of measurement. We have types of shows televised by a network. It lists types like comedy, drama, sports, etc. If you think about the qualifications of each level of measurement, the first thing you should look at is that these are categorical data, qualitative data. Only the first two levels include qualitative data. Then you look at whether there's an order or rank associated with the data. The types of shows are not listed with any information related to their ranks in viewing or anything like that, so these data belong in the nominal level. The second row shows ratings descriptions for movies. Even though there is minimal numeric information involved, there is a rating involved in understanding these data entries. Because they are qualitative, they must be part of one of the first two levels. But the ranking aspect is what puts this list in the second level or ordinal level. This next example includes only numbers, so it can't be the first level. So when we look at what can be done with the numbers and what sort of function a zero represents in this list, that will help us determine what category belongs to. The data is a listing of temperatures, so as we discussed before, they can be subtracted, which puts them in one of the two later levels. But a zero in this listing would only mean a certain place on the temperature scale, not the absence of temperature. So these belong in the interval level. The last example is precipitation, and you may be tempted to treat it the same way as temperatures, but you need to give it a little bit more thought. First of all, the data are numbers, so it can't be the first level. There's more than ranking involved, so it's one of the last two. Precipitation can be both subtracted and divided, or put in ratios. So it's probably the last level, ratio level. But our last qualification tells us for sure. A zero entry means the absence of precipitation, so it is inherent. This data set is definitely at the ratio level of measurement. Let's try a few on your own. The first data set is the top 5 U.S. occupations with the most job growth projected for 2029, and the second is movie genres. Pause the video while you think about these first two. Here's the solution. The first data set is at the ordinal level. It does more than just list the different occupations. It ranks them in terms of their potential to grow, a ranking which may or may not be numerical. Job ranking could reflect actual job openings or the ease or ability to be promoted to these positions. Differences between these entries are not meaningful mathematically because they're still categorical in nature. Registered nurses minus fast food and counter workers is not something we can calculate. Now the second data set is at the nominal level. No mathematical computations can be made, and the listing cannot be ranked. Let's look at another few sets. Pause the video and label these two data sets at the appropriate level of measurement: nominal, ordinal, interval, or ratio. The third set has quantitative data, and differences between two dates does give us useful information. However, year 0 would not mean the absence of time, and dividing 2 years by each other would not make sense. So this data set is at the interval level of measurement. The last set is quantitative, and both differences and ratio of number of home runs totals make sense in evaluating the data. Also, a 0 would mean no home runs were made, which would definitely affect the data. That means this set is at the ratio level of measurement. Here's a quick summary of the different levels of measurement of data and how to distinguish them. Feel free to copy down this chart and refer to it as you work with differentiating data sets. As you can see, as you move up in level, there's a little bit more you can do with each data set. Well, I hope this has been helpful. Please make sure to let me know if you have questions, and I'll see you in the next video.